Friends, good morning everyone. Good morning. Am I audible? Voice clear? Good morning, Arvind. Good morning. Yes, okay. Other students? Good morning, blank. The blank. Good morning to all of you. I hope that after breakfast you are recharged and you will listen to the class carefully, writing the notes properly, have revised the previous lecture, recalled it 3 times. Good morning, Nirmala. Good morning, Harika. So what about the learning part going on? Is learning you are doing regularly, learning, recalling minimum 3 to 5 times same day. Whenever lecture there, same day. Blank is doing good, very good. Good morning, Spurti. Other students, ask yourself, are you doing that one? Good morning, Ram Areti. Very good, Arvind is doing it. Other students, what about your status? Spurti doing, Sobia, good morning, beta. Are you regularly learning properly so that if you close the notebook and then you recall the points, are you able to recall? That is the learning. Not just reading 5 times. Okay, I'm reading 5 times. Good morning, honey. Good morning. Yes, beta. Very good. Harika doing it. Very good. Nirmala doing good. Good. Other students also make this habit. From the beginning onwards, your fight is there. Every day, tough time because learning, writing, learning, recalling, solving, it is not easy. Yeah, Sai, yes, beta. And it is not easy. Nobody enjoys daily work. Understand one thing. But the purpose, the goal is motivating for you. But otherwise, who likes everyday work? Yeah, tell me, who likes? Even the toppers, if you find that nobody likes, but the purpose is clear that I have to be there, I have to be selected, and that journey is like this. Those who are not going through that tough work, they are not be consistent, they will not find up to that part easily. It will be delayed, it will be delayed, it will be delayed. So be smart enough that yes, yeah, what is required, I'll do it. It doesn't matter I like or I don't like, I will do it. I'll thoroughly learn it, recall it, solve the module, solve the NCRT, PYQs, and I am packed. I have no other time, no other distraction. Okay, so by this time, we have done what? In this periodic table chapter, we have started with the introduction part, stories were there, Newlands, Dober-Near triads, then Lothar-Meyer classification, Mendeleev periodic classification, then modern periodic table. In modern, we focused upon the different blocks were there, SP, DF, journal terms, general configuration. Like here, we have done this page. This page we have done. This we are not focused. Why? These are obsolete. So generally, we do not discuss much about them. Journal overview is required. That time we can refer it. Then this portion we have discussed. This part, not every line. You have to read the every line. Any line you find important, mark it. Otherwise, then you can leave also. Which are important ones that in the notes, and then you can refer the NCRT. This is important. Among them, which is incorrect given in NCRT, 111 and 110. These two names. 104 is controversial earlier. Two names given. One is Kurchatovium and other one is Rutherfordium. Finally, RF. Okay, then this portion we have discussed, but still you will read it. Which are inner transition elements, lanthanoids, actinoids. Which orbitals are filled? That also in the last yesterday lecture we have done. That second period, how many electrons filled? That many elements. Seventh period, how many orbitals are filled? These four, 32 elements. Take that part in the last lecture we have discussed. This question, have you tried 3.2? Have you tried this question 3.2? 3.2. Tried it or not? This question. After the yesterday's class, learning, then NCERT reading, that involves this portion. जागो जागो दुनिया वालों, जागो जल्दी से जागो. Answer नहीं आ रहा भाई. Who has done this question yesterday? How many of you done yesterday only? Now not trying. I am saying yesterday. How many of you have done this? Honestly, they have done. 3.2. One student done, Harika. Okay. Other students. How many of you have done this one? Okay. Honey student has done. Any other? Yesterday that question they have done it. ज्योति ने डन किया, बहुत बढ़िया. 3 स्टूडेंट्स. ఒకటి రెండు మూడు स्टूडेंट्स. अरविंद कोठारी ने किया, चलो ठीक है. फार कह रहा हूँ. 4 स्टूडेंट्स. बनोत ने किया, वेरी गुड. बनोत, यस, गुड. राहुल, यस. टुडे अर्ली मॉर्निंग डन. ठीक है, इट इज ऑल्सो गुड यार, बट ट्राई सेम डे यस्टरडे. गेटिंग इट साई. अगन नंदू, यस, वेरी गुड यार. Those who have done it yesterday, it means they are trying their level best. It is not easy, as I said. Sometimes you are not getting the time, but in mind, the concept should be clear. I will try same day learning. That is more retention for you. More easily you will recall also later. ठीक है, that example we have done yesterday. All stories are given here. Still you will read that stories. S block journal configuration. Here marked which are metals, metalloids. You can roughly go through that portion also. Then here some properties are given that you will read it, but with the time in the chapters, these terms will come. Metallic character and everything. है ना? P block, we have written already. Representative elements. Chalcogens, oxygen family. All this we have discussed, not in detail with the information given. Transuranium elements after uranium, that we will consider as transuranium. Problem 3.3. 120. If it is there, you will consider which period it will be. 118 is 7th. 119 theoretically should be 8th. And group 1. And 120 group 2. Over. That is the question given. Still read that portion. How many non-metals, how many percentage of metals are there? Journal properties are given here. And some are semi-metals, which are metalloids, and they have given non-metals. Generally, they are gases or solids at room temperature. General terms all. Yeah. Getting it? This is given. ठीक है? Now, yesterday we have discussed which part? Last part. Honey, yes, I will take. Yesterday we have done which part yesterday? Did I start Z effective? Z effective we have done. ठीक है, Z effective done. Periodic trend done or not? Z effective. Left to right along the period, left top to bottom along the group. Okay, up to the periodic trend we have done. Now in NCERT, if you have read yesterday, Z effective separate topic is not given. है ना? Z effective separate topic is not given. rather in the ionization enthalpy. They have explained this term, ionization enthalpy relation, they have explained by using this term. So if you have not marked yesterday, you can mark these lines. Like here. On which page they are? Page number I'll tell. Page number 88. Page number 88, right column. Page number 88, right column it is. These trends are given. Okay, here. Attraction of electrons towards the nucleus. And simultaneously, which factor working? Simultaneously, repulsion of inner shell electrons from each other. That we have discussed yesterday, that the electron is experiencing the attraction force of nucleus simultaneously repelled by which one? By the inner core electrons. The effective nuclear charge experienced by that you can also mark, experienced by the valence electron. Experienced by the valence electron in an atom will be less than the actual charge on the nucleus. Remember why it is less than the actual charge? Because of the repulsion factor or the shielding effect due to the inner shell electrons present. Like example, 2s electron of lithium is shielded by the nucleus inner electrons of 1s. बोलो आई बात समझ में? Given in NCERT, but very precisely given. It is important, yes. It is very important because we are going to relate the properties or some trends by using the directly Z effective. Clear है भाई ये बात? Up to this part clear? All clear? ठीक है, आगे बढ़े, स्टार्ट करें आगे. Periodic trend done, left to right along the period. Z effective dominates, increases. Top to bottom along the group, Z effective almost constant because new shells adding and attraction of the new electron with the nucleus is almost constant, not increasing. Attraction force not increasing. ठीक है? Now after that we will talk about atomic radius. ठीक? We will talk about atomic radius. That means now properties will start. And how atomic radius experimentally it is observed? Experimentally it is by X-ray techniques or spectroscopic methods. By which way? Experimentally atomic radii by X-ray or spectroscopic methods, which is beyond the scope of our book. In our book we will relate or compare that one. ठीक है? Our target will be comparison and understanding the trends. तो स्टार्ट करते हैं भाई, कहानी शुरू करें. तो लास्ट क्लास में वी हैव डिस्कस्ड अबाउट द Z effective, है ना? That part we have discussed in last class. Now today, before starting the trends in atomic radius, I'll firstly discuss what are the types of radius given there. Atomic radius. What is the meaning of atomic radius? It is a distance of what? Distance from the center of nucleus till the outermost shell where electrons are present. This is what it is the meaning of atomic radius, distance between nucleus and outermost shell or valence shell. Getting the general meaning, atomic radius. Can we find out atomic radius of atom easily? It is very difficult because its size very small, 1.2 10 to the power minus 10, which is given in the previous page. We have underlined it also here. This one, 1.2 10 to the minus 10 meters or 1.2 angstrom. That is the order of the atomic radius. Getting it? This is the atomic radius, the distance from the nucleus to the outermost shell where electrons are present. That is the general meaning of atomic radius. Now, what are the types there? One is covalent radius. Covalent radius is what? Covalent radius is when we find out, so here when you read the page, it is given we find the radius approximately when they are in what? Bonded state. So when we talk about covalent radius, then these atoms are what? Two atoms are there, A, molecule it is. This distance is internuclear distance. This is what? Internuclear distance is D. So R covalent will be what? It is equal to half of the internuclear distance. Half of the internuclear distance. Between two atoms in a covalently bonded state. In which one? In a covalently bonded state. Half of the internuclear distance. Isn't it exactly half? So it is covalently bonded atoms. There we are finding approximately half distance, internuclear distance. That is considered to be covalent radius. Next term, metallic radius. Or it is also termed as crystal radius. metallic radius. In metallic radius, metal atoms, they are present in the metallic bond. So again meaning will be what? R metallic is equal to D by 2. What is D here? Half of the, D is what? Internuclear distance between the atoms which are in which bond? Metallic bond. So you can mention here half of the internuclear distance between atoms in a metallic bond. In a metallic bond. Written. Then third one is which radius? Van der Waals radius. Third is van der Waals radius. What is van der Waals radius? Van der Waals radius, where it is generally in inert gases or in molecules also, both. Mostly we use in inert gases. Or in non-metals molecules. Now in van der Waals radius, it can be represented like this. Now what happens in the van der Waals radius? This is a molecule, covalent radius involved. It is a molecule, covalent radius involved, right? And these are two adjacent atoms. Yes or no? Adjacent atoms in neighboring molecules. But they are in non-bonded state. They are in non-bonded state. Therefore, here it is half of the distance. Half of the distance between adjacent atoms. Between adjacent atoms in neighboring molecules. In non-bonded state. In non-bonded state. In non-bonded state. It is measured in solid state. It is measured in solid state. It is measured in solid state. It is half of the distance between adjacent atoms in neighboring molecules in a non-bonded. So here it is non-bonded. The maximum radius will be van der Waals. So if we compare among them, order among these three, maximum will be van der Waals radius. Then comes metallic, and then comes covalent. It is the order of radius, VMC, van der Waals, metallic, and covalent. Because in covalent, what happens? Some overlapping of the orbitals takes place, so distance is least among them, and van der Waals is in non-bonded state, maximum distance. Bolo bhai, till this point clear? General terms, metallic, covalent, and van der Waals. Up to this point, now we have discussed the atomic radius types. Now what are the factors that affect the atomic radius? Bolo bhai, bolo. Factors affecting the atomic radius or atomic size. Suppose as Z effective increases, what will be the effect? Atomic radius or atomic size? As shell increases, atomic radius order or atomic radius should be. What will be the order? Z effective increases. What will be the effect of Z effective? Atomic radius will decrease. Why? Because Z effective is basically attractive force of the nucleus. If that is increasing on the valence electron, it will be tightly bound. And if it is tightly bound, distance from the nucleus less, hence atomic size will decrease. And shells keep on increasing. As shells keep on increasing, distance of the electron from the nucleus will be more. More distance from the nucleus, more will be the atomic size or atomic radius. Then sigma is shielding effect. As shielding effect increases, shielding effect means what? Blocking of the nucleus charge. More is the blocking of the nucleus charge or more inertial repulsions. The distance of the electron from the nucleus will increase, hence atomic radius will increase. So more shielding effect, more will be the atomic radius. Then if D and F orbital electrons, whenever D and F subshells are there, they have poor shielding effect. Maximum shielding by S, then P, then D and F. D and F are what? They are diffused orbitals. More diffused, they have poor and poor shielding effect. So whenever the poor shielding effect is there, the attraction of the nucleus will dominate, and then Z effective increases, atomic radius decreases. आई बात समझ में? तो what is the periodicity order in atomic radius or atomic size? What is the pattern? The pattern is first one along the period. Along the period from left to right, what will be observed? Atomic radius generally increases or decreases? Atomic radius decreases. Reason? Since which will increase along the period, attractive forces are dominating. So that is how Z effective you can relate. Left to right along the period, what increases? Attractive forces increasing, electrons more tightly bound, hence atomic radius decreases. Then second periodic trend is what? Along the group. From top to bottom. Along the group, which factor will be there? Atomic radius will increase. Reason? Z effective has not impact that time normally. Which will be there? Since what is increasing? Shells keep on increasing. First period, then second, then third, then fourth, like this. As shells keep on adding, distance of valence electron from nucleus will increase. More and more distance increasing, atomic radius will increase. बोलो भाई, आई बात समझ में? Till this point, confirm? Now we will talk about that general trend is what? Periodicity. Left to right, top to bottom. That is the general trend. Like example, general trend. This is lithium, sodium up to cesium. Normal trend top to bottom, keep on increasing. ठीक है? General atomic size or atomic radius trend. Any doubts in that? Normal trend, top to bottom, along the group. 11th thing. In third one, lithium, beryllium, boron, carbon, nitrogen, oxygen. Along the period, atomic radius decreases. In fourth, decreases. Remember one thing, we are not comparing here inert gases. ठीक है ना? We are not comparing here inert gases because in inert gases we use van der Waals radii. Whenever in the material you get any question where inert gas is compared with the same period element, generally you will get answer is given inert gases because which radii involved? Van der Waals. This point clear? Whenever any example given in the material, that comparison of atomic radius or size of the atom, atomic size, if inert gas is coming, answer you will check, definitely inert gas will be given considering which radius involved? Van der Waals radius. Which radius given? Van der Waals radius. But when you read NCERT, such comparisons should not be drawn. Such comparisons should not be drawn like here. If you have NCERT, you can mark also. ये देखो ये वाला atomic radii of noble gases are not considered here. So whenever you compare them, we are not considering here atomic radii of inert gases. Reason given, being monoatomic, their non-bonded radii values are very large. Which are that non-bonded radii value? Van der Waals radii. ठीक है? In fact, noble gases radii should be compared not with the covalent radii. आई बात समझ में? So whenever in the material you will get, it is just because of van der Waals radius they want to give the answer. But in real, we never compare the van der Waals radii inert gas example with covalent radii comparison. Bolo, till this point clear? So in example, you will not get generally standard example where inert gas with other covalent radii. In material given, mark it for the sake of van der Waals radius is compared. ठीक है भाई? Till this point. Now some exceptions which are not following this general trend. Which are those exceptions which are not following this general trend? Like radius of aluminium and radius of gallium. Already we have learned their mnemonic or groups. Group number 13. Related in group number 13, which elements are there? Bolo. Boron, aluminium, gallium, indium, thallium. That we have discussed. Now, if you go by general order, what should be the general order? Top to bottom. It is not period, it is along the group. Top to bottom, it should increase. But in real, what is observed? that radius of aluminium is slightly more than radius of gallium. Very closer value, slightly more for aluminium. ठीक है? Is it the regular pattern? No. Is it the regular pattern, periodic pattern? No. That's why we are discussing those examples which are exception and they are important from the exam point of view. ठीक. Now what is the reason for that? What is the reason? Reason for gallium, smaller radius as compared to aluminium. Aluminium, inert gas 3s2 3p1. Gallium after zinc. Next is gallium, which is 31. It will be argon, then it will be 3d10, 4s2 and 4p1. So among them, how can we explain that this order is not matching with the periodic trend? We have to explain it that due to poor shielding of 10d electrons. Due to poor shielding of 10d electrons, Z effective increases. Bolo. Till this point, getting it? Due to poor shielding of 10d electrons, Z effective increases and hence atomic radii decreases. Up to this point, Pakka? Clear? Here, next example, where also variation is there. Important example, here in this chapter not given, but it is commonly discussed here, later in the D and F block elements chapter. Radius of zirconium and hafnium. They are very close values. Zirconium and hafnium. It is from which group? Group number 4, scandium, then titanium. This is 3D, it is 4D, it is 5D series. ठीक है ना? 3D series, 4D series element and 5D. So here what happens? That this is the more, no doubt, but it is approximately closer values. Logically, what should be the answer? Top to bottom along the group. Hafnium should be more as compared to zirconium, which is more as compared to titanium. Take periodic trend, but not following. That's why exceptional observation is there, and that examples are important, which are separately discussed in the NCERT in maybe this chapter or other chapter. So why hafnium size is less than, almost similar like, which one? Zirconium. What's the reason? If you remember, we have learned in F block elements that in F block in 5D series, which will be coming, which electrons will be coming? 4F series electrons are coming. Yes, due to F electrons, we have learned that F orbitals have poor shielding effect. Clear? So here the reason is due to poor shielding, of 4F electrons in 5D series, due to poor shielding effect of 4F electrons in 5D series, Z effective increases and atomic radius decreases. This is known as lanthanoid contraction. This is known as lanthanoid contraction. Meaning clear? That due to lanthanoid contraction, we can explain why zirconium and hafnium, they are closer in their atomic radius because of the which concept working due to the poor shielding effect in that one 5D series element, which is here hafnium. Due to poor shielding effect, it means the Z effective dominating in such a manner, the increase in atomic radius is almost similar, not higher, just like regular trend. So wherever periodic trends not followed, those examples separately we have to cover. Okay, otherwise what is the answer always? Top to bottom increases and left to right decreases. Top to bottom increases and left to right decreases. Suppose this example I am giving. Radius trend. Scandium, deuterium, lanthanum. Think about it. Among these three, done. In this case, is it following the regular trend or exceptional behavior? Is it following regular trend or exceptional behavior? It is a regular trend. Why? Because in lanthanum, no F electrons. No lanthanoid contraction. Getting it? So journal answer always there if exceptions are not observed. We cannot apply these exceptions in all cases, no. Periodic trend we follow maximum, but wherever not followed, we know by the results that this is not matching. Then theories are framed to explain that exceptional behavior. So this is which element? It is group number 3. Scandium and ये किसकी कहानी है भाई? It is from group number 3. But in group 4 onwards, from group 4 to 12, then we can apply which concept? Lanthanoid contraction. Now other exceptional behavior is in 3D series. From scandium to zinc. Another exceptional behavior is in 3D series. From scandium to zinc. What should be the journal order? From scandium to zinc. If the periodic trend we discuss, what should be the journal order there? From scandium to zinc. Yes, logically, periodically trend. It should favor from scandium till zinc. It should regular decrease. ठीक? But the observation is not matching with the periodic trend. It means कुछ गड़बड़ है ना? It means कुछ गड़बड़ हुआ. क्या गड़बड़ होता है? Initially, what is observed? It decreases. Then, in the middle, almost same or almost similar values. Similar means close values vary. And at the end increases. That is the trend. That initially scandium till almost Mn, it remains decreasing. Then in the middle, Mn, Fe, cobalt, almost till nickel, it will be almost which values? Similar values, close values. And then in the end, from copper to zinc, it again increases. So initially decrease, then in the middle almost similar values, and at the end it increases. Almost similar values will be there. And at the end here also increases, here also decreasing. Now what is the reason for that? For this exception, how can we explain that reason? Batao, how can we explain that this observation, because which is not following the regular trend, that we try to explain by using the other theoretical points. Sai saying Z effective shielding, good one. Any other point? ठीक है, initial trend is what? Left to right decreases. Why? Generally Z effective dominate. What happened after that? That when pairing of electrons will start, due to pairing of electrons, one concept which we can use here is due to pairing of electrons, some inter-electronic repulsions are there. Due to such factor, the inter-electronic repulsions and the attractive force of nucleus, Z effective, they start cancelling out or compensating each other. That is why in the middle, the regular decrease in the atomic radius is not there. So till this point, normal trend, pairing will not start. It will go like this. Then when pairing will start, some inter-electronic repulsions, or you can say metallic bonding also becomes weak here because of the pairing will start. Here it is, unpaired electron, stronger metallic bonding. General theory is like this. And when the repulsion factor also there, the Z effective will not increase. It will be somewhat compensated, cancelling out each other. And at the end, due to the fully filled orbitals, high inter-electronic repulsions. And due to that, the Z effective not dominate, rather repulsion dominate. Rather what dominates? Repulsion factor dominates. Getting the meaning? So this trend is important, will be in D and F block you will get, or in the module also here possible. Initial decrease due to Z effective, attractive forces dominating. In the middle, inter-electronic repulsions compensating with Z effective, and at the end, inter-electronic repulsions dominated, which is observed in their atomic radii increase. Bolo, till this point, getting it? Bolo, till this point clear? Important are which one? Reason also okay, fine, I'll write the reason. Initially, which dominates? Z effective dominates, which is the regular periodic trend. In the middle, Z effective and inter-electronic repulsions due to pairing of electrons in the orbitals. What happens? They start cancelling out, or you can say they start compensating each other. Hence, the decrease in the atomic radius will not be observed much. And at the end, बोलो लिख लिया ये? Getting the reason? Naidu, Fayazun. Getting it? Meaning? Okay, so that is the meaning of exceptional behavior in the which one? 3D series. Now, if one question I ask related to order. This is difference in the atomic size of the elements marked as P, R and S. Difference. So what should be the correct order? It is difference in the atomic radius or difference in atomic size. Li with Na, potassium and rubidium, cesium and francium. Among these, which option is best? Which option correct? अरे क्यों कहां से आ गया यार? PRS लिया है ना? ओहो, आई हैव रिटन ऑप्शन क्यू. ठीक है, इसको चेंज कर देते हैं. इसको हमने पता नहीं कहां से लिख दिया ये. क्यू कर दो. Clear? S is not there. PRQ is written. Okay, students are saying, Kirtani saying 3. Why 3, Kirtani? Rahul saying 3, blank saying 1, Dikshit saying 3. Anyone, reason? Reason, bhai, if it is 3, if it is 1, if it is 2, increase is more observed. Yeah, Kirtani, if increase is more observed, reason why? If you are considering option number 2 or 3 or 1, anyone can give reason? Here they belongs to which one? What's the difference will come? Second shell, na? That involves which one? Difference will be of 3D here. Here 2s1, then come 2p and 3s. 2p is coming. Between them, which is coming 3D. And here, which is coming 4f. The gap is coming. Which orbitals are involved? This one. Now tell among them where poorest shielding. Where poorest shielding? With which electrons? Whenever poorest shielding effect is there, the size will increase more or less. When poor shielding effect is there, then between the two elements, the size increase will be very less. That is why among them, the smallest gap in the atomic radius is where Q, then d orbitals also poor shielding, and maximum will be in P. So answer is third. So those who are getting 3, you mention the reason, which orbitals involved here, 4f between these two, poor shielding effect. Finally, the increase in the radius or size will be very less, difference Q will be least. आई कहानी समझ में? पक्का? Getting it? Then you will go to then you will go to the graph like this here. Given that graph, top to bottom, along the period it is lithium till fluorine, continuous decrease is there. Then similarly here, that we have discussed now, no? That pattern is here mentioned. Getting it? So by that difference is coming more. That difference coming more, reason getting it? That graph clear? So you will complete up to this part. In reading part, you will complete up to this, up to the atomic radius. Ionic radius we will not discuss today. Rather, we will discuss in the next class. ठीक है? Atomic radius today. Radius will not be there. Up to the Z effective and periodic trend will be there. Radius will not be there, but you will not think about that only. Whatever done in class, do it. Recall 3 to 5 times, solve the module. But syllabus is up to which part? Periodic trend of Z effective. I'll check the syllabus. Here it is mentioned, I think. In LT syllabus, introduction is there, triads, Mendeleev, modern, nomenclature, electronic configuration, types, blocks, prediction, Z effective and its periodic trends. Getting it? So test syllabus completed, but the focus is now that you will solve more questions as per the class completion. Do not stop, do not break at a point that, okay, it is done, I will not do anything. Complete from your end completely. And recall, revise, solve module, everything. Now, any point you want to ask from the test syllabus? Any point you want to ask from test syllabus? Yes, student saying I have not taken online. But online to going on here. You can go for the any lecture in the channel. It will be available or not? Gosalites channel. Tell. अच्छा, only YouTube you have take. So beta, it's up to you now. If you want, you can go ahead. If you don't want, it's up to you. But wherever go, I am telling, be consistent. Here, there, anywhere. But be consistent, work regularly, and be ready for tough tests also. Do not cry that oh, tough test beyond this and that. This year we have seen anything variations they are doing some changes or like this, so you will be also mentally ready. Wherever go, wish you all the very best, honey. Work hard. Till that time it is available, utilize the source. Then up to you. Any other student, any question you want to ask? Any point? Test syllabus up to. Any question up to the test syllabus? Any page of NCRT which you have gone through and you want to ask that line or that paragraph? Done? So that is the part today we have started, which was with atomic radius. Next class, I'll recall the points, or before class starting, you recall the points, and we'll start with the next portion, which is ionic radius, then IE, ionization enthalpy, and so on. Honey, how is it possible, yeah? Full syllabus on YouTube. If we give like this, then what will happen? You know. So no, it is I think only given for few days, na? It will be for few days. Then it will be separate app is there. In that app, login will be given, and then you can access it. Just like ABC classes were given, na? That is similarly we are doing now YouTube classes, and then it will be shifted to normal app. Those who have joined properly Sri Gosalites, they will be in that app. Fees, yeah, I don't know. I am not into that part. You can talk to Prasad ji is there, na? Other staff members are there. You have the number or not? I'll give their number. Talk to them. Boys campus. Honey, I think you are a boy. That's why I'll give the staff number to you. You have the number or not? Acha, you have that one. Okay, so I will give you number of. Okay, I'm giving you number of Prasad ji, na? He is dealing with all. Or they will give you the number of relevant person further if required in girls campus. ठीक है बेटा, got it? ठीक है, that person you can talk in admin, they will guide you. And in girls campus, one more number I will give. Selja madam is there. ठीक है ना? You can get the details all from them. Prasad ji, you can directly call. If he is not picking, then girls campus, Selja ma'am will take care. And if subject wise you want to ask anything in my track, which topic or what is going, then I will tell. ठीक है भाई, मिलेंगे फिर अगली बार. Take care. Bye bye. Thank you.